Hello and welcome. I'm Bill Wake. We're here working on Dijkstra's shunting-yard algorithm. It's an algorithm to convert postfix expressions to infix expressions. We've done a bit of work already. Actually, we've got it working for some subset of operators. And we're about to do some refactoring. And I want to add an evaluation component today to push things on the stack and actually compute the value of the expression. So here's the problem. You got an infix expression, just a normal arithmetic expression like you learned in grade school. 3 plus 4 times 5 minus 2. We could have parentheses. And we're going to convert it to postfix, which says when you have the tree form of this, take the left subtree, the right subtree, and the root. And that gives you the postfix. So 3 plus 4, well, the 4 is really 4 times 5 because times has priority. So 3, 4, 5 times, that gives us the 4 times 5 subtree. Then a plus gives us the 3 plus that. And then 2 minus gives us the rest of the tree. And then to evaluate it, you push things on the stack, numbers on the stack, 3, 4, 5. And then when you see an operator, you evaluate the operator, 4 times 5, 20, and push the result, and so on. So we'll add that last part today, I hope. Okay, so Dijkstra's algorithm, he visualizes it as a shunting yard, which is how they manage trains. So if you have a train and you want to shift some cars to another train or something like that, you can move the front end past and leave the cars you want to move unhooked, and the engine drives past. You move those cars down into the stack, and then when you've got all the cars you want, you uncouple it and back up the engine and then go forward, and you've got fewer cars. All right. And the way this works is the input string, like 3 plus 4 times 5, it's going to say numbers just pass straight through. They're like the engine going through. Operators, we're probably going to push them on the stack, but if there's anything on the stack that's higher precedence, we want to pop that off first. And so our 3 plus 4 times 5, when it sees this times, it's got the plus on the stack, and it says, hey, plus, are you higher precedence than me? No, then stay on the stack. I'm higher precedence, I'll go on top. And, at some point in the future, let's say the minus comes in, 3 plus 4 times 5 minus 2. The minus says, hey, are you bigger than, higher priority than me or equal? And the star is definitely higher. The plus is equal and left associative, so they both go to the output side. And then the minus gets pushed and the 2 comes over and the stack gets emptied at the end. All right. Let's go to the IDE. Okay, so we've one thing I noticed when I ran the tests, we've added more delays lately. The delays help us when we're running the algorithm visualization. They're great because then we can see things moving around and we feel like, oh, it's visualized. They're not so great when you're running your unit tests. So at this point, they're up to 144 seconds. I also switched simulators because I think I found a slightly faster simulator, at least for startup purposes of our tests. But let's see. We want, okay, prefix converter. Yeah, I just don't need to compare anymore. Let me see. Did I check in what we did? I did not. Let me do that real quickly. Well, we basically did this thing on top about refactor replace. Okay, that part we did. Okay, so we had a stack that did a normal isEmpty test for no items left, but we're instead adding this bottom element and setting a precedence on it so we can make our comparisons of popping things off the stack be more equal, more similar. All right, and I added this note about reduced delay. So for now, we're refactoring. So let's turn it into something that's tolerable to us. I'll run the tests again. They're going to take a lot less than 144 seconds. And what that tells me is it reaffirms what I was saying yesterday, that this delay value probably doesn't belong in this class. It's something that should be controlled outside. And we certainly want to be able to swap it so the delay is, quick in the unit tests like just now, or slow when we're visualizing. And, that's a lot of time difference. All right. So because we're going to do a lot of refactoring to start with, we'll just leave it there at 500, and then we'll come back and refactor that too. So let's make this reflect reality. Refactor, replace algorithm use. Okay, so that part we did. Now we want to make, oops. Let's capture this down here. That was last time. And then today, I still can't type the year, 5 months in. All right, and today we're going to work on the algorithm. And I think we'll do just this part. Okay. And prefix converter. Well, let's look at 107 first and then 89. Okay. So 107, we're in this loop here. We're checking while the precedence, basically this is pop the remaining stack. And we have an end of input that has a precedence lower than all the other inputs, but higher than that bottom of stack marker. So we're using this flag value, if you want to say it that way. But the stack is while precedence less than something, do a delay, add to the output, and pop. Okay, let's go to 89. I don't think I can get them all quite on the screen here. No. But same thing, while precedence versus stack.top, we got symbol, not symbol, sleep delay, output add, stack top, and stack pop. Okay, so the only difference in these is this is symbol and this is not. So this, just as a technique for doing these replacements, I like to get things very similar textually so that I'm not having to think about, is this the same or not the same? It's like, here's the identical text, I'm extracting it and doing it. So we will do that too. Some days you can extract to a variable, and we'll call it symbol just to make sure that we can make the name. Okay, so symbol, well, who calls this? All right, so this is really the body of symbol, except let's find its caller. There's only one caller up here. Well, maybe we can extract this like this. The symbol should be outside the extract method. The phase should be outside because these 89's in a different phase. Okay. But we can extract method on here. All right, and this is pop. How about higher precedence operators? Okay. Now, if you're being extra careful, I'll demonstrate that. I'm going to do the same thing here, extract a method, and I don't care if it's called extracted func because I'm not going to worry about the name, but I'm going to put it right next to the other one. Pop higher precedence, and here is extracted func. And I can make sure these are exactly the same other than the function name. Okay. And, yeah, it's a pity. The tools, I don't know, maybe I should switch to app code because I know it has the IntelliJ style refactorings, but like I can verify this manually. I can even go out to a diff tool or find one in here if I have to, but it's 4 lines. I think I can trust myself. One thing I can do once I have it isolated like that is I could say, really, this is the same as calling pop higher precedence operators with symbol. With symbol. Okay. Yeah. Now I lost it. Pop higher precedence. Here's extracted. Okay. And then now there's no reason for extracted to exist. I would ideally inline it, but we don't have inline support. So I'm just going to take this line. I'm going to put it in here up where extracted function of symbol is. And that can go there. Okay. And now this should be a no change to our tests. I still have some junk. I gotta make sure it works before I totally delete it. In this case, I probably should have just made that line in the caller in the first place. Okay, so this function is no longer being used. Okay, and then pop higher precedence, I'm going to push that down because it's if we're telling a story from the top, then these two are doing the same thing. Okay, so this is pop higher precedence. Pop remaining stack is pop higher precedence. And then I would inline this again. So I pulled it to a variable to get it out of the way. Now I'm going to put it back. And this is really, really too bad. I'm trying to get rid of more stuff. Okay, so this one, handle an operator, is the one that happens while we have more input. Then at the end we have pop remaining stack, and we're done. I feel like there's still more we can do, and I'm debating about whether this phase stuff could go back in to the caller. I almost think it could. Let's inline this. So pop remaining stack is up here. Process input. Well, we didn't really say anything at the beginning. Okay, but I did get rid of this now. I think that's an improvement. It's somewhat... There's something a little weird that there's set phase here and no set phase there. All right, but the other thing I can do, so yeah, one thing going on here is this end of input thing. We can fold this together if we could arrange our input differently. Let's put it that way. Right now, when you the only place that we use this end of input is here, I think. Let's find usages. Callers. Definition. Callers. Well, let's use good old find. Okay, it's in there, and we use it here. Yeah, so, all right, so I think, well, let's see. I'm trying to get rid of the need to do this at all. All right. And my interpretation is, okay, what happens if we put that end of input on the end of the input? Hey, crazy idea, right? Then our last statement right, that pops all the stuff. Okay, does somebody, where's convert? He pops the bottom of the stack again. Okay, let's highlight him a little bit. Okay, so my idea is, what if input string has one more input dot add prefix dot end of input? All right, then our main loop, the last time through, it's gonna empty out. The symbol is not a number. It's not parens. It's one of these. It's going to empty out the stack. And then, sorry, here, handle operator is going to empty out the stack and push that end of input. Okay. So this is kind of an algorithm change, but it's a refactoring in the sense that I want to behave the same in the end. And so I'm saying I'm trying to drive these behaviors to be the same. So at the end, I would just like to pop the end of input symbol. It'll be on the stack and pop it. And that would be after this loop. Okay, so let's try that. Let's see, are we checked in? No. Have I run tests recently? I don't know. Now, you saw it run quickly, and here it is running slowly, but not as slow. I guess I can live with a few seconds. All right, so let's commit this. We merged of the stack clearing methods. Okay. That was pretty, we got the text completely the same. That's understandable. What I'm saying this time is, and call it what you want, but I'm saying I'm going to push end of input onto the input stream. Okay. Set input. At the very end here, I'm going to add that character. And this is very common in compiler land. You have a set of tokens. One of the jobs of your lexical analysis, your lexical analyzer usually takes the raw input file with characters and produces tokens that, maybe it tells where the location of the character is. If it's an operator, it puts the precedence and, helpful information for this token. And one of the things it often does is it appends a special token to the end of the stream that says the input is over. And this lets your loops, you don't have to search for empty end of file and worry about that stuff. You just go until you hit that token that says the input ended. And I'm trying to do the same thing here. I'm putting this prefix converter dot end of input at the end of our input set. All right. And now we have to make sure that it's okay. All right. So we're doing input is empty. Let's go look at a queue. I think we have a front, right? Yeah. So we can change our loop. I'm going to do it in smaller steps then. So instead of doing while not input is empty, I'm going to say while input dot front not equal prefix converter dot end of input. Okay. So I'm pushing this at the, it's kind of like what we do with the bottom on the stack. I'm pushing this to the end of my input stream. I'm changing my loop to look for that. When it hits the prefix converter dot end of input, it's done. All right. And theoretically we could, well, in effect, we should remove that character. We've only peeked at it, and at the end we're saying it shouldn't be there. Okay, and everything else should be alike. And I can even, well, that's okay. We'll do it here for now. All right. So my prediction is this should be a refactoring, that nobody should be changed by this. And we'll find out in 0.873 seconds. Okay. All right. Well, that's a good thing now. So now that I talked you into having it there, all right. What I'm thinking is this, if we let this into the loop, so if we put our loop back to while input is not empty, this symbol would come through, input.front, remove it from the list, which is what we do want. And it's not number, it's not list, it's not that. It's going to be a handle operator, which is going to pop the higher precedence operators and push the symbol. Okay, so the effect of this will be at the moment we finish with this, we'll have emptied out our stack, because this is lower than everything except bottom. So all those people in the precedence greater than or equal are going to be on the output side now. And our stack will look like bottom, end of input. And that's actually good. This means we have one more symbol pushed on the stack. Okay, so instead of removing it from the input now, I'm going to remove it from the stack. And that's with a pop. I'm going to change this back to not input dot is empty. Okay, so if I diff, they look very similar now. Okay, that's the active page. Where's the diff? Okay, so we've added an input here. We've changed, we've said we got an extra thing on the stack, we need to pop it. Okay, I feel like there's something we're missing. That's the only two changes. Okay, I believe we're trying to get this to run equivalently. We got rid of this pop. The input gets removed up here. Up here. Okay. All right. So again, it's kind of, I don't know if you want to call it refactoring or algorithm replacement or what, but I'm trying to do it in as tiny pieces as I can to migrate from one algorithm to the other. Sometimes the algorithms are so different. I mean, if you're replacing a bubble sort with a quick sort, you're probably better off getting it working on the side, maybe running it in parallel to make sure both algorithms do the same thing, and then swapping in the new algorithm. In this case, I've been taking small steps to convert one to the other, and if I wanted to go backwards, I'd have some work to do. I'd have to revert a couple versions. All right, now let's see. Let me see where we're at. Okay, we got bottom is on the stack. And I guess our clear operations, everything got cleared out okay, because that was one thing we were testing to make sure output and stack are empty at the end of the process. Okay. And I don't know, I don't put a lot of comments in, but this is one of those places I might. And I got one more loop. Okay, let's check this in. Okay, so we'll use end of input as a flag. As sentinel is maybe a good word on the input stream. And using that to force pop of everything else at the end. Okay. Now, we're definitely changing his algorithm here, because here's what I'm saying. I believe, okay, go back to the top of the algorithm. We're gonna, this is the bottom. So we call our local convert. Okay. And it says process input to output and pop remaining stack. My contention is what's on the stack at this point is bottom. And we're forcing it. We're saying if the end of input stream was here, you would dump everything out, right? Except bottom, because bottom is not going to be higher precedence than that. So the claim is this phase just went away. All right. So this is the sort of thing that happens with sentinel values. Oops, sorry, bumping my camera. It happens with sentinel values. You can simplify the algorithm. All right, now hopefully the tests run. Otherwise, I just made a liar out of myself. Yeah. So because we knew that we were forcing that thing in the end of the input, and it's lower than everything except the bottom, it would force everything off the stack as the very last thing through the loop. Okay, so we've switched a little bit away from Dijkstra's version. All right, now this is a one-liner that says the thing. I would be comfortable just doing this, an effective inline. All right, let's make sure that's good. All right, so pop higher precedence operators. I mean, the word higher is not really conducive to what we're saying. Pop. What? I mean, if I just say pop, how about pop operators by precedence? And you could look in the method and see the details on what that means. Well, I've kept my running streak this week. I don't think I've typed precedence right once on the first try. Okay. Well, let's turn on our numbers back up to a high number, and let's run. Well, no, let me run tests once first. All right, and commit that. So what we did was we said removed the need to pop all operators at end because end of input already forces it. Okay, now we'll turn this off and do a run. We still got one more loop. I mean, we have 2 loops on stacks. There's this other one. And I'm going to see if there's some tricks we can do there too. I don't know. I'm supposed to call them techniques. All right, so we're going to expect to see a $ showing up in the stack. Is that true? I guess maybe at the very end. I don't know if we'll have time to look at it, but notice it's on our input stream now. 3 plus goes in, 4 is going to move over, times is going to go on the stack. Okay, 5 moves over. Now $ is going to pop things, pop, pop. And okay, and I think it briefly went on there, but we didn't get much chance to look at it. But that's good. I mean, I'm happy with that. All right, let's go back to refactoring mode and change this to 500. Isn't this boring to change this over and over? We should make something where a computer does it for us. All right, let's look at this stuff. Okay, so the situation is you have 1 or more left parentheses on the stack. Okay, and what I would like to think, I mean, in the inside, it's doing the same thing. Let's go down here. The pop operators by precedence, if we could arrange for the symbol to be, well, we can, I think we already have that. If you pop everything until you hit a left parenthesis, right? Because there's not going to be, I mean, the left parenthesis by precedence, let's go up to the top. Left parenthesis is less than right parenthesis. So if you popped whatever's on the stack, any normal operators, plus, minus, times, divide, if any of those are on the stack, underneath it's going to be a left parenthesis. There could be more left parentheses and operators in the stack, but we have a right parenthesis on the front. Let's see, my hand's in view. So the right parenthesis, let's see, that looks like a left to you, so I got to change my hands around. Okay. The right parenthesis comes in, and everything on the stack is going to be higher than it until you hit that left parenthesis on the bottom, or maybe in the middle, but on the bottom of those higher precedence operators. All right, so if we pop until we get lower precedence, then we'll pop until the right parenthesis is at the top of the stack, and then we want to pop the right parenthesis. So I think again we've got the mechanism to do it. Let's see. So instead of looking for this stuff, we're going to call our method pop operators by precedence, and I'm going to say symbol is equal to right parenthesis. Okay, so this is my claim, is that takes care of that, and then the pop here is the left parenthesis. Okay, and let's see if this runs. Now, if things, well, we're consuming the symbol. We've already consumed it. We don't push it ever, so that's all fine. Let's see, handle operator. The difference is that one pushes. Okay. All right, so we've got these 3 stacks we've been playing with. We got them down to 1. Okay, with a little bit of stuff going on beneath. Maybe end of input symbol would be a little more clear. Okay, well, the input's not empty. Grab the thing from the front. If it's a number, pass it through. If it's a left parenthesis, just push it. We don't want to pop stuff that's higher precedence because we're trying to keep that stuff all on the stack already. Now this one, let's compare this clause to handle operator. Pop operators by precedence and push symbol. All right, and in our case, we're going to pop that other thing. Okay. Yeah, that's passing. All right, am I happy? Well, what's making me unhappy is I'm looking at code that's like similar, but it's hard to see the similarity, and that's a bad sign in my book. Part of the problem is, notice we're not doing the delays and the phases and all that stuff. That's really the difference. But it would be nice if we could see, I don't know, does this make sense to, yeah, I mean they're different enough, but I want to get them all at a similar-ish level. But I also see I've got this competition. I also want to get some explanation going in this part of the algorithm, because right now the right parenthesis is just going to unload operators and then quickly pop without a delay here like we had for the push. Okay, so this is going to be, I'll call this handle right parenthesis. And I think yes. If I weren't doing the visualizations and I just had 2 lines like that on both these, I'd be very tempted to leave them there. And this one too. I mean, this function stuff is I'd be happy if this thing were, if symbol is number, output add symbol, otherwise push a left parenthesis, otherwise where'd it go, above? Pop to with the right parenthesis and then pop the left parenthesis. Oh, interesting. I kept the comment on that line. Okay. And then the other case would be pop operators by precedence and push. Okay. Let's move this one down. Pass through. All right. So I think, one of my goals with the algorithm visualization is I'd like to take a plain old algorithm, minimally annotate it, and have it be visualized at some level. It's not going to be a perfect, you could make a fancier custom visualization, but I'm pretty sure I could narrate what was going on there, maybe slow it down another notch, but that's and I don't think I've mutilated it in a sense. I mean, this breakdown is not horrible. but it is hiding stuff. I mean, this algorithm would be 10 lines or something, right? I mean, maybe 12 or 15, but not a whole lot. And I feel like that smallness is gone now, because when we started it, we looked at it and we're like, hey, here's this loop. You could probably do this in 4 or 5 instructions in assembly language. That's really a nice, powerful thing. And that's probably still true, but you're not going to see it from all this mechanism that's here. So can you refactor too much? Yeah, I think, if I didn't have the annotations, I would call this too much. I think, seeing the cases and what they do explained straight in a straightforward way would be a good thing. All right. So to continue the theme here of annotating and all this, we're going to say handle left parenthesis, because we want the parallelism that we can see, that everything's done consistently. Okay, left parenthesis. All right, and this should pass tests. And what I'm seeing is I'm not consistent about the set phase stuff. All right, and we'll let the test pass, hopefully. All right, so we extract methods for left and right parentheses. Okay. I think that's, well, if it's going to be broken out and some things are there, this is at least mostly consistent level. A little bit low sometimes, but I think that's okay. All right, let's take a couple minute break, 2 or 3 minutes at most. And what I want to do when we come back, let's see, I want to make sure the timing works. One thing is, I think every time you do a set phase, you really need to do a delay. And we need to make sure that the delays correspond. Like, I think you should probably delay. Let's see, I think you should probably set the phase and then delay. But I want to fold those in so that that's just consistent with what's going on. And yeah, let's do that. We'll come back and do that. And then I think we'll go ahead and set up a second stack and start evaluating these things, just to show, like, end to end, this whole thing would make sense. If you were, I don't know, creating a calculator in the old days, right? Something like this, a little tiny loop, 4 or 5 cases in it, and it produces the input you need. And then an evaluation loop is, again, it's like loop over the stack, while the stack's not empty, push things in, pop them off. It's you got 2 cases there, the operator and the symbol number. All right, 2 or 3 minutes. Bye. Hello, welcome back. All right, let's check our to-do. Are we keeping up with what's going on here? Whoops. Yeah, we extract a method. All right, but what really that was fold all 3 loops to empty the stack into one method. Okay, I think that's something we can say we did. Previous number. Okay, so yeah, so I want to make this set phase. I'd like to make it so set phase also puts its sleep in. So let's, and I think that's always going to be right. The only one I'm not sure about is this one here. But I think each of our methods should say what phase they are. So again, this stuff is kind of meta. It's outside the algorithm per se. Handle left parenthesis. And this is handle right parenthesis. Pop by precedence. Okay. Yep. That set phase and that sets phase. Okay. So everybody does a set phase before their step. The methods, let's see, down here, we're delaying in the loop so you can watch things pop. So I don't think we have to say anything extra there. All right. So I'm going to say you should delay, and I guess we can do it in our own thread before we switch over. I'm going to say every set phase should have a delay before you change the wording. No, it should be after. You change the wording and we pause long enough to let you read what phase we're now in. All right, that seems good. Let's see who can eliminate because of this. Phase is start. I think we should do this. Starts unknown. When you do convert is when we're actually starting. All right, let's use our mechanism. Okay, so what we'll do now is we'll question each delay, and obviously the opposite is finish, right? Okay. Push converted up bottom input string. Okay, we don't care about the input process. Now this, I think this delay, because every branch through this thing is going to hit a set phase, this delay is not going to be necessary. All right, now our set phase delays, delay. This one is set phase with operator, push operator. Okay, and again, I think it'll work out. This one, we've already said we're popping. All right. And then we're delaying as we do them. I think that's okay, just so we can see them popping. All right. And let's change it back to the right time for humans. And run it and watch it. All right. So we'll do 1 plus parenthesis 2 plus 2 minus 3 times 4 minus 1. Okay, B. Okay, start. Pass 1 through. Well, our screens, let's see if I can. Notice we got the 2 parentheses. We're handling the right parentheses. Pop, pop. we popped the bottom parenthesis. Okay, 1, 2, 3, 4. All right, and then 3 gets 3 times 4, and then the 2 minus, then the 1 plus, then the tail it with 1 minus. Okay, the only one I thought was quick was handle right parenthesis. Let's just double check how that's looking. Handle right parenthesis. Set phase handle. So that should have paused. Okay. Oh, it probably went to handle operated by precedence really quickly. Okay, I think that's better. I'm going to call this trace. I'm trying to think of a good name for things as I want to move it over. And I want this to be okay, and this is message. All right. So everybody's saying trace this, trace that. I think that's better looking. Eventually it's going to say like viz.trace for the visualizer. Okay. See if there's anything else I don't want to leave. All right, so the two things I know we still have open. One is I would like to pass in the output and the input. Let's see if our to-do says that. I think it does. Yes. Pass input and output to prefix converter. I don't care about right associative. We know what to do. It's right associative comes up if operators are equal precedence. If they're equal, then and they're right associative, you don't pop the one that's already on the stack. So 2 to the 3 to the 4, it's going to have 2 goes through, the exponent goes down, 3 goes through, and then you got exponent on the stack and exponent on the input. It's like, should I pop this one off or not? Well, if it's left associative, you should pop it off. If it's not, you should not. And then it ends up with 2 symbols on the stack. And then the last number goes through 4, and then clear the stack. Okay. Reduce delay in tests. Well, let's say automatically. We can make that some sort of variable thing in another component. All right. Yeah. And then I think what we're really going to do is evaluation. All right, because we got basically an hour left. So I want to make sure we get the evaluation done, and then the rest of this is all future improvements, I guess. All right. So we'd like to, well, we want to visualize it. Visualize evaluation. And we want to implement the algorithm. Okay. And I'm putting visualize first. We'll stub out enough to get it going, and then see where we are. All right. Now, I don't know, space-wise, let's do this one again with the thing sideways. That's a little better. The output and the input are both going to be more or less the same size, so I don't think there's so much issue there. Yeah. Yeah, the space squeeze was more from the other side. But if I stick another stack in there, how's that going to look? Well, we'll see. All right, so we need a, I don't know, evaluator or something like that. And then, oh, yeah, no, I need to slow down on the main thread, I think. I just go back. Ben Franklin had this great saying that was something like, "It's amazing and wonderful to be a rational creature because then you can find reasons to do whatever you want." And I feel like I'm doing the same thing here. So I'm gonna update the screen and then I want to just stop. Okay, I don't know that that's the issue, but I'm just thinking it might be. Run in main thread should be synchronous. No, I guess I'm convincing myself the other way now. Because setting this thing, if we sleep before we release from doing it, then I don't think we can update. Well, we'll see what it looks like. Yeah, that's backwards. Oh. Huh, they're there. Something's definitely funny in the thing. Ugh. Okay, let's revert that file. Okay, where were we? Content view. So we have the queue view. I guess we're going to have another stack is what the deal is. And we don't have a converter. We need an evaluator coming in too. So, maybe we can, maybe we should do this in the other order. Let's create the object, an evaluator. It will have a stack. And then once that stack exists, we can push it in here. Okay, so let's see down here. Evaluator tests. Okay, and my first test is going to be, well, let's make one. And he needs input, he needs a stack. He needs a working stack, and he needs to know the input queue. Do we have to tell it in the constructor? I think maybe we do. I mean, we could let it create the stack itself, and maybe that's what we did for the other one. Let me go find shunt-yard prefix converter, I guess. Well, he definitely creates his own stack. Nothing comes into him. We should make him take these things too, and we'll get to there, I hope. All right, let's give him the queue, if nothing else. All right, so let queue queue of let's make it character. Oh, I guess. Yeah, that should work okay. Okay, evaluator with input. And then is there anything we want to assert? Let's assert. Well, maybe we'll let's assert true. Evaluator dot stack dot is empty. Okay, and I think we're saying starts with an empty stack is all we're proving with that. It may be too wimpy of a test, but it gets us going. All right, let's add a new file. And sometimes I just do it right in place. But we'll make an evaluator. And class evaluator. It's going to own a, well, it's an observable object. And I guess what requires that is the visualization, so I'm jumping the gun a little. It's got some fields. It's got an init, which takes a Q. And I'm going to say character just so we're not fighting it too much, I guess. All right. And up here, we're going to make one. Q be of type Q of character. And we'll assign it. And then we also asserted that there was a stack of characters, and let's make it not empty just to kind of X marks the wrong spot. Okay. This should now fail. Right. Take out this junk we put in. I have no idea what delay we have in there. 500, okay. This should pass now. Okay. Is that enough to draw with? I think we can do something now. All right, so where's our top level? App. So I don't know if we can assign in here. Yeah, that's not gonna work. I guess we can do it here. Var converter equals prefix converter. And let's see if we can pass that in. Why the templates aren't indented properly, I don't know. All right, I think this should be the same running, and we have a short delay, so it'll zip, zip, zip. Okay, let's see. I don't think we need to prove anything other than things are hooked up and working. Yeah. Okay. Yeah, so now I'm going to add in this extra argument. I also want to pass in evaluator is a new evaluator with converter dot output. Okay, so I'm trying to hook up the output of what we have. Oh, are you going to be? Okay, yeah. I want to hook up the output from the converter, the shunting-yard algorithm, to the input of my evaluator. And we need to make the content view prepared to accept an evaluator in here. And observed object variable evaluator of evaluator. It's like writing Java. All right, that's there. We need it down here too. Well, we can do the same sort of thing. I think, again, we got an observable object for the converter, so we're going to say converter equals prefix converter. And this is the right-hand side display over here. Let's just use converter. And the evaluator is evaluator with converter.output. All right. Converter cannot be used on type content previews. Converter. I think let's build it and see if it's still unhappy. Why not? Have I used the name? I don't think I've spelled anything wrong. Converter preview. All right, I think I was forcing it to grab the one up there maybe. No, it's still not happy. Instance member converter. Preview cannot be used on type converter previews. Can it be a let? Yeah. Do I have to do a binding anything? Remove the $sign. Oh, let me hit the books. I may dump the preview and just not worry about it. But with state object. let me try again. Swift UI preview with state object. Probably too much. I don't know about you. I find this very hard to read. So the state object. Okay, that's the app. Come on. So where's our data? Oh, well, that does suggest my app should be using a state object, maybe. App. Since it's the thing that owns state object is I'm the owner of this actual class object, and state is I'm the owner of this struct. Observed object says I'm a reference to this object. Okay. Let's see the converter content view again. Now, I don't know if that's going to help us any. Yeah, that's too much to track through. Structuring switch UI previews. Okay, maybe. Okay, there's the home view, there's state. I'm giving this a few more seconds and then where's the preview? Preview provider. Game.example. So it looks like he's just got a game object that's going to provide some stuff statically. Okay. Is that coming after? Well, I could definitely learn to use previews better. Let's take this out though for now. We've gotten so little benefit from that evaluator. Okay, but this should still work. The startup has gone back to being slowish again. One plus 2 times 3. We have no delays. Yeah. Okay, the right stuff's happening. All right, so where are we? We've got the app, creates the prefix converter, creates the evaluator, and hands it in. And then over here, content view is going to own an evaluator now. In the long run, these two output and input will also be created and passed in, I think. Well, they probably should be created in the app level and then passed into the constructor. Okay, we have an evaluator, so we can look at its stack. And that is evaluator.stack. Okay. And if I run, I mean, no test is driving this. This is part of our visualization. I mean, there are ways to test some of this stuff more than I'm doing, but I don't know. And I also wonder, it's like, is it the fact that I had it horizontal slowing it down? Who knows? I'm not quite clear why Apple thinks these notch here is such a good thing, but several models have it. 2 times 2, just to be different. Yeah, okay, and we got the stack there. All right. Now I think we're ready to go. So we put in an added evaluator holding an empty stack. Added it to the view. All right, and now let's go back into algorithm land and just work on our evaluator tests. And I'm going to reorder that. Whoops. You know, you make it hard for me here. Okay. Life's too short. Okay, evaluator tests. So the way this works is, well, the algorithm is pretty simple. You go through the input. If it's a number, push it. If it's an operator, pop the arguments, evaluate, and push the result. And that's really all that can happen. I guess at the end, there's one value on the stack. How about the value of the expression is on the stack? So we've got infix to prefix converter and then a prefix evaluator that produces the value. Okay, so simple ones to start with. Let's just test one number. Now, what's on the stack should be numbers. And we'll find that out. I don't know. Well, I don't know if our views and stuff are ready for that, but let's see. All right, so the test is we got to have a queue, and we got to have an evaluator. Okay, so the queue is, we're going to add some stuff to the input. 7, and then we're going to call call evaluate. I don't think he needs to be past the input every time. Okay. And then we should assert that 7, well, so, people write them both ways. Assert that evaluator.stack.top is the number 7. All right, and we need to go to evaluator. All right, so 2 issues: the type of the stack and the lack of an evaluate method. Okay, the stack is really stack of int, and the evaluate method we will add. All right, should compile, should fail. Just deleted it. All right, fine. And it should blow up because we have nothing on the stack. Yep, unexpectedly found nil. Well, unwrapping an optional. Okay. We don't need the rest of the test to run. And evaluate then. Well, the quick way would be stack.push7. And let's see if that does it, and then we'll work our way back. Kind of a fake it till you make it strategy. This gives us the minimal thing. Okay, and we'll generalize it. So one thing is, while the input is not empty, we need to input dot woof. Oh, let's change this to input. Input dot front, and then we're going to remove the input. Remove. Okay, and that should be equally good. Well, that's, well, yep, still passing. Okay. So instead of pushing the 7, I really want to convert my input. Let number equal input dot, symbol is a character now. Is there like a 2 number or something like that? Can I do int of symbol? Yeah, text will give me an optional int. Symbol. Can I do that? I don't know about character. Now, okay, symbol dot. oops, description. And let's push that number. And again, I'm just trying to piecemeal shove this thing into shape, but we've got this main input loop. I think that's the right thing in the long run. You might wish we'd generalized a little more. Maybe I should have just done the conversion and called it a wrap. Okay, but we've got so now we work if you have only a simple number on the input side, then that's what we display. All right, now I think I'm going to go back to our view and our go button. We did converter.clear, converter.convert. We also ought to do evaluator.evaluate now that we have something. And let's run and see what we got. So I should be able to put a single digit in. All our numbers are single digits because we don't have a fancy Lexer to gather them up into numbers. Again, in real life, these will be tokens coming in from the lexical analysis to the parser. All right, so if I enter 7, it should be fine. If I enter 1 plus 2, it's not going to work. Well, we'll enter 9 just for variety. Done. Oh. Oh, we haven't made things published. Okay. In here, we don't need to publish this cube, but we do need to publish this. I have to be a var, yeah. Okay. And we are modifying it, so yeah, it counts. One of the things that's going on with this visualization is we're putting stuff in that's more, I mean, normally I would have this split out more and not try and visualize it from the algorithm itself. But the mechanism, what I'm hoping is the easy mechanism. And my plan is I've got a few more algorithms I want to explore. Maybe I'll go back and we did an operator precedence parser and we did a recursive descent parser earlier without visualization. Maybe it'd be nice to just go in and do some sort of visualization on those, but we'll see. Okay, so we're going to get a text and this time we'll do 0. Should go all the way through. Ugh. What's going on? And maybe I'd be better off getting the algorithm right and then worrying about this. But clear, converter, convert, and evaluate. And let me just at least put this thing out there. Evaluator.stack.top. Okay, so we should be able to print that. It may be a display issue. Let's look at our stack view. I feel like I'm getting more and more bouncing around instead of... Okay, so he's got to be hashable and custom string convertible. Integer is okay from that, otherwise it wouldn't compile. I guess. All right. So I'm going to run it. Let's see if it prints, just so I can understand if it's even running. But regardless, I want to go get the algorithm right and then come back on the view if that works. I do tend to get bouncing around sometimes a little too much. Right, so we'll take a text. I'll just do 4 this time. And I want it to go all the way over to the left. Okay, so we push. What? Something's really weird. I'm wondering if I got these things hooked up right. All right, we're gonna focus on the algorithm, get the algorithm right, and then figure out the visualization consequences, I guess. Okay, so where's my? See, it's Control Command up arrow. So the next thing you can do is, well, you can basically have some operators on there. And we're going to do the same kind of thing. We'll add 7, we'll add 3, evaluate, and, oh, we need to add a plus. Seven plus 3, if you evaluate it, it should get 10 on the top of its stack. Oh, this has to be in the other order. We're supposed to send it the prefix or postfix form. Postfix is operands operator. Okay. This test will fail. Hopefully for the right reasons. I expect it will push 7, push 3, and then have some trouble with the plus sign. But if it does push it, well, it may push something like it, I guess. But yeah, okay. Evaluator 22. Yeah, because this conversion doesn't work if the number is not a digit. Okay. So we need to break the two cases. If symbol is a digit, a number is number, then we're going to do this stuff. Else we got to do something else. All right, and the something else depends on the operator. So let's, well, we're just doing plus. Let's just do it this way. So let value 1 equal stack dot pop. Well, let's call it value R because it's the right hand side, equal stack dot pop. Value left equals stack dot pop. And stack dot push. Value L plus value R. All right, so I'm doing something. Oh no. It's, oh, stack dot top. And also, I don't have a combined operator for possibly poor reasons, but okay. So pop the left, pop the right, pop the left, push their sum. And I don't think there'll be a problem now because this symbol description is not going to attempt to convert plus into an int. In a real situation, real compiler, I would have to be a lot more careful about sizes of values and all that stuff. And a lot of that might delegate into the, we'd have to delegate that into the token analysis and so on. Okay, so plus works. So what are we going to do here? Well, let's basically we're only working with binary operators, and let's make a method out of this. Extracted function. This is I'll just call it do it. It's going to be what the operator does. I'm going to move it down. Okay, so that, but I also want to know the symbol, so let's add that in as well. Symbol of type character, and we'll pass symbol here. All right, so I'm just isolating the actual computation so I can make my other operators work. And we'll let that run. Okay. And this will be test all operators. Okay. So if we do 7, 3 plus, well, let's do our, how about our 1 plus 2, 1, 2, 3, and then let's add times plus, and then divided by 7, put add 7, and input.add slash, and input.add one and minus. Okay, if I've calculated this right, we're going to get a 0 out of all this mess. Okay, maybe that's a bad one to do. Let's do how about 10? Oh, we can't do multiple digits. Let's do minus 3. Okay, we should get minus 2 out of this. So 1, 2, 3 times plus is 1 plus 2 times 3 is 7. Divided by 7 is 1. Minus 3 is minus 2. And I believe this will fail because we got symbols that don't mean their own meaning. This is going to be 1 plus 6, 13, 16 maybe, if it treats everything as plus. And I'm doing a slightly bigger step, right? Yep, 16. Okay. In here, let's switch on symbol. Symbol, and we can say case. We guess we want plus, minus, times, divide. Okay, this is our plus. We have to have a default, and I'll just return -1. Again, we're not error checking really, Just trying to get the values in. Plus, minus, times, and divide. Okay, so somebody's got to do the work to convert our operators into some sort of function or application or something. All right, this should pass. All right, so we've got our evaluator. I really should have taken that printout, shouldn't I? Okay, but now what's going on? Okay, we have a converter and an evaluator. We think from the app, this should create the converter, and then the output Q should be referenced. Ooh, is that? It should be the same object, right? Okay, let's check our input before we go any further. Content view. I don't think we'll need the app anymore. Okay. Let's look at converter.output.description. Okay. I want to make sure that the output is actually being filled in before we try and evaluate. And then I should have printed the other one too. Okay, we'll do 1 plus 2. And I'm expecting it to print 1, 2 plus. Where's that being called from? Stack found nil. All right, let's print stack.top. I shouldn't be doing that. Did it print before we got here? Maybe that's my question. Yes, it did. 1, 2 plus. Okay, now let's print evaluator.input.description. Okay, these should match. If they don't, that tells me something is really weird. Tells me my objects aren't hooked up the way I thought they were. Now I think we're passing a reference, I believe. I don't think there's an issue there. Swift does copy arrays when it assigns them and stuff like that, so you do get some unexpected, well, at least unexpected for me. Okay, so 4 times 5. Wow. Okay, let's make sure we didn't do anything stupid. The input to the evaluator should be the output from the description. That should have been hooked up by our caller. which was the app that I said we wouldn't need anymore. That thing is creating a converter, and he's passing in converter.output. I shouldn't need to make an actual reference, should I? I mean, that would seem really weird. All right, let's make a test and just check it. I'm just doing an arbitrary test location, but if I do test hookup, let's get this. Let's let converter equal converter, prefix converter. And then our input is going to be converter dot input. Sorry, output. Okay. We create the converter. It's got an output field, which is a Q. Our input, let me just pass it directly and make sure there's no funny stuff going on this way. Okay. If I put something in the queue, well, let me do it. Let's do this. Converter dot input dot add 7 converter dot convert. Oh, that takes the input string. Okay. Convert 7. Then it should, well, let's assert equal. Then converter dot output dot front should be character 7. Let's do this after. Okay, if I created it, I convert 7. The converter output should be that. And then if I call evaluator.evaluate, well, at this point, I should also be able to say converter dot output dot front should be 7. All right. This, okay, so create a converter, connect the evaluator to its output, and run a conversion through. That should move 7 from the input through the stack to the output, and it should be there on the front. This should be evaluator.input, which is converter.output. All right, let's see what we got. Now maybe we have to check our clear. That's the one that, like, is it resetting it or is it creating a new instance? Not evaluator, but converter. Yeah, look at that. Okay. I don't know if we have output dot. Yeah, those are our classes. I think clear maybe belongs on those. All right, let's deactivate that and see. Oh no, I think I can make my test fail. The real code calls converter.clear before it calls convert. And so, okay, yeah, I think that's what's going on. The real code's calling clear. It's replacing our input queue and our output queue. And that means the one we hooked up is not being used anymore rather than doing a reset on it. So we're going to go back and touch up those arguments to add the stack to add a clear. Unexpectedly found nil. Okay, and if I comment them out, well, the other tests might fail. The test for clear might fail, but this one should pass. If hooking up works. Did you already run? I thought that was suspiciously fast. Yep. Okay. All right. So what do we need to do? Well, let's add a method on these three. Q tests. All right. Add an item is not empty. Okay. Test clear removes all items. My 3-minute drill here. This should be assert true. If we do q.clear, which doesn't exist, test should fail. And I hope there's something that resets the queue. One failure, good. Still didn't add up. Well, let's make it up. Q dot remove all. Perhaps a better name. We'll do the same thing in the stack. Practically the same test, at least conceptually. Let that pass before I change. What's the deal? Oh. Yeah, we know that's gonna, oops. We know that's gonna fail for now, but otherwise it passed. Okay, let me go to the stack tests. I'm trying to do this without enough time. Well, next week I'm only going to be here Tuesday. I think we'll wrap this stuff up, and then I'm going to spend the time trying to figure out how to package. Come watch me read documentation and mess it up 100 times, but that's the deal. Um, that's what we'll be doing anyway. So if I do a stack and I push my stack, all right. No method. All right, so it's 3 o'clock. We'll leave a failing test there that will remind us what to do, and I'll put a little note in the to-do file as well. But I think we've got the mechanics of the evaluation working. We're working on the visualization, getting that connected properly, and I think if we had made the input and output queues be separate objects in the first place, maybe this wouldn't have been quite the issue. But we have a failing test, and we can make that go. So thanks for joining me. I hope to catch you again. Have a good weekend. Bye bye.